Hello, robotics enthusiasts. My name is Andreas, and I'm glad that you found my channel Robotics Friday. I also have a more or less regular newsletter on LinkedIn. This is actually how it all started, but that's a completely different story for maybe another video. And in one of those editions, I promised you to make my own private, let's say, wrap-up from Automatica show in Munich. As I already mentioned, I had very intense discussions during these 2 days in Munich, and so I decided to break it down into several videos. And this one is the first. So during my stay in Munich, there was one specific question which I had in my mind and which I also wanted to discuss with different experts from the industry to get different opportunities on that topic. And that is the global lack of skilled workers. Supposing you are the owner of a small, medium-sized company and you are forced literally to automate in order to stay in business. So the question is, where would you start? And how would you start with automation? In this episode, we start in the beginning of your process. We start with the application and the specific requirements of such applications, like, for example, welding. And we are asking the question, how can you benefit eventually from simulation? Is there a way to take out the complexity if you set up such processes? In the first part of my interview with Jens Fetzer from Cenit, we will learn what exactly can be simulated and how you can benefit from it in the real world. So before we start, I want to ask you to support this channel by liking this video, subscribing to the channel, and hit the bell so you get notified if the next episode is being published. And now, let's roll the intro and get started.
I'm working with the company Cenit. Cenit is a German-based company listed on the stock exchange. We're headquartered in Stuttgart. We have 800 to 1,000 employees at the moment. We have several divisions. The majority of our business circles around digitalization. We are developing our own 3D simulation product called Fast Suite, which is in brief a 3D based simulation platform to enable and support automation processes based on robots, robot process integration, offline programming, commissioning. Technically, if you look at industrial robots and the applications, we have to provide an environment to build up this robot cell that we are looking at in a virtual world. So it's a kind of digital twin or a digital copy of the real environment. That also includes that we have capabilities to include the toolings and the fixturings as mechatronic models. But then our focus is that we can directly load the CAD data from engineering and we use them for CAD-based path planning. We have a deep dive technology integration to support all the different applications like arc welding, laser cutting, gluing, painting, whatever. And at the end, we create the robot code, we can validate it, and we can make sure that the production runs efficiently. There are several customer problems that we are solving. The biggest problem for customers is that by teaching robots, they have too much downtime. We give the promise to do it offline, to define everything offline, to optimize everything offline without interrupting the ongoing production. That's one promise. The second thing is to ensure a constant process quality no matter what operator is using the system. We have a shortfall of skilled workers, and the software enables customers to capture the manufacturing know-how in recipes and templates. Another aspect is also paperless process support. So what we figure out that in manufacturing, a lot of robot operators need to define processes that are previously defined in engineering departments. They type it in again. And we want to avoid that. We can also discuss with customers how we can, for example, directly reuse the already existing engineering information, not only the CAD data, but also weld line definitions or process points or cutting contours, etc., like a kind of feature-based programming. And we use that in order to have a digital continuity of the data from engineering to the shop floor. We want to be as close as possible to reality when it comes to simulation, because we want to give reliability to the operators that what they see in the simulation is exactly what happens on the real robot. In terms of path planning, in terms of collision avoidance, reachability, etc., we have to be safe. What we are technically not simulating is the weld process itself. We are simulating the kinematics, the dynamics of the robot system. In some applications, like painting for example, we can also kind of simulate the process result, because then the programmer can not only see if the robot motion is okay, but also if the process result is good. And if not, he can optimize it offline. And when we combine everything with a good robot setup, with a good calibration, with a good integration of the process parameters and technologies, at the end we can achieve that customers can create new projects offline and they can directly execute the result on the robot cell with nearly no touch-up at the rear robot cell. A typical application is arc welding with robots. There are more and more companies offering standardized robot cells or special robot cells, and they are more or less standard for what they do. The cells don't change, but what is changing is the fixture and the parts. So when they produce something, they need to prepare the next job, and they can do it offline. And when the preparation is done, they make a download on the robot cell and they can start production. The systems are getting more and more advanced also with regards to technology like sensors and cameras and vision systems, seam tracking, touch sensing, etc. And all these more intelligence that you put in the robot cells helps to reduce the touch-up time on the robot cell. We do have customers that are very successful with an automatic offline process, no touch-up anymore.
Ooh, that was an interesting start. I never thought about how could simulation actually help you to cope with the lack of skilled labor. In the second part of the interview, I wanted to know if you can also benefit from simulation if you have a cobot. Because let's face it, this is how they are sold. They are easy to use, they're easy to program, easy to set up, so why should you even bother buying simulation software? But you will see there's going to be an interesting twist.
It's an interesting thing. For me, it is not a contradiction. So I understand that cobot systems come along with the promise that you don't need a software to teach them. You can teach them by dragging and indicating things, using the teach pattern to define the parameters. Yeah, but that means, again, no matter if it's an industrial robot that you teach or a cobot robot that you teach, that means that you stop production, you teach, and you interrupt your money-making process, and you prepare the next thing. So the argument of offline programming is also valid for all the cobot systems. Secondly, when you teach, you limit the applications to the things that you can teach. Again, arc welding, you have to ensure a certain process orientation, like welding from verticals, etc., etc. So in order to support this, also cobot systems come along with positioners to move the part during the process. Here I say it makes sense to think about a software for programming, because teaching those things is very complicated and time consuming. And that's why a cobot is definitely a good door opener, because it takes away the complexity of a robot, or let's say the assumed complexity of the robot. In fact, also a cobot has a control and needs to be programmed. So no matter if it's an industrial robot or a cobot, from my perspective, the promise is a little bit less safety equipment. So an industrial robot you have to protect. A cobot, you can be more tolerant here, and yes, you have some more flexibilities with those systems, and cobots are relieving the threshold to enter into automation. So if there is a customer asking, should I start with a cobot or should I wait? I say, start. Start with a cobot, but when you figure out that a cobot welding is too time consuming to teach, come back to us and we have a software for programming.
So as usual, there is no either or decision, cobot or simulation. It really all comes down to your process, to your requirements, and it really depends on your environment, which is the best solution. But generally speaking, the more complex your processes are, the more you can benefit from simulation tools. Just think about having an additional sandbox for your complete process where you can try out new things, where you can set up new parts, where you can optimize, and everything can be done really offline. In the next part, Jens is wrapping up the pros of simulating your processes for you.
What is the advantage of an offline programming software like we have it? No matter if it's a cobot system or a classical industrial robot. The advantage is I have CAD-based path planning. I can create a complex trajectory with the minimum points in a good and standard quality repetitively. It's not dependent on the user, it's not dependent on the operator, it's not dependent on the, let's say, luck and situation and teaching. It's mathematically defined. Secondly, everything we teach is not only motions, but we also have process commands, parameters, signals, etc. A software solution can help to automatically preset those commands. So when you teach something, you need to also enter those things and cycles in the teach panel, and an offline software can automatically do that. A third thing is repetibility. So you have similar parts, and a software can help you to find similarities and to copy, paste, and transfer and transmit things you have done, while when you teach it, you start from scratch all over again.
Oh boy, I promise. Should I ever start welding with a cobot? This is going to be a no-brainer. I'm going to need such a simulation tool because it not only can cut down the commissioning time of my robot process itself, I also get direct access to all the process expertise, which apparently I'm lacking. In the last part of the interview, Jens explains which processes benefit the most from having a virtual sandbox.
Let's come from the type of operation. So we have point-based operations, pick and place, spot welding, screwing. Then we have curve-based operations that can be arc welding, which is a typical use case, gluing, deburring, laser cutting. And we have surface-based operations that can be grinding, polishing, painting, shot peening, coating, etc. And we are also looking into some volumetric applications like 3D build-up of 3D printing. So every time where we talk about a discrete simulation where we have a geometry defining the trajectory of the robot. Machine tending automation, so when a robot is loading, unloading a machine, and while having the part in the hand, you can also do some deburring operations. And so you're combining several units to a production cell. Coordinated robots, so coordinated motions, 2 or 3 robots working on a dynamic positioners, but also a production cell where several robots are cooperating together. Each of them are executing single operations and everything is orchestrated with a PLC control, etc. So also this is in scope of our application. So we can start small, but we can also grow up and support bigger requirements of customers. And when you look at production companies who have a big part variant and a low volume production with high variance and a lot of design changes, etc. Also this reuse of existing projects for the next job. So all the capturing the good experience for the next job that you do is a very crucial thing. And we have, it's not a question necessarily of functionality, but also integration know-how, methodology, how to use it in order to take advantage of the capabilities that a software brings. And that's what we also do in addition to the pure software functionality. So this consultancy job, this process integration job.
I hope you found this interview with Jens Fetzer from Cenit as interesting as I did. And if you haven't done so, please leave a like and subscribe to my channel. At this point, I have to say thank you to Jens Fetzer and to Lumi Dokia from Cenit for making this video interview possible during Automatica. Thanks for watching. See you next time.